Hello, welcome to Lesson 5, Solutions, Suspensions, and Colloids. So today we're learning to use data to identify and understand the different kinds of liquid mixtures. Okay, so we're going to talk about what a solution is, a suspension, a colloid. Let's go. So, solutions. Some chemicals, like water, have properties that dissolve other chemicals. And this dissolving or dissolution is when the molecules in it, the atoms break apart. Okay? And waters and chemicals that do this, like I said, are called solvents. This dissolved chemical, we call it the solute, and it's not visible because it's broken up into its component atoms. Okay, here's a little animation that kind of shows you what's going on in a sense. So solvents bond with the solute, they dissolve, and they temporarily disrupt those bonds. And a really important part of this is it's a temporary thing. These solutions have the solute and solvent mixed homogeneously, meaning that it's all equal. There's not like different parts in different places. You can't easily separate these, in part because how do you sift atoms apart? Now, this dissolving is not technically a chemical reaction in the traditional sense. If you have salt dissolved in the water, if we evaporate the water, boil it off, like you see in this GIF here, the salt is left behind. Okay, so the next one is suspensions. Now, in a suspension, a solid or liquid is added to a liquid or gas, and it cannot dissolve in it. And some examples would be if you stir some mud or dirt into water like we did. Having some flour stirred into water is a kind of suspension. If you see Febreze or dust kind of floating in the air. And when you mix suspensions, the individual particles can usually be visible. Sometimes they're not, as in the case here. And after some time, the particles will settle out, and they're deposited as sediment at the bottom of the liquid or gas that they're in. So that dust floating in the air eventually falls to the ground. The Febreze eventually falls to the ground. The sand eventually kind of just slowly filters down until you have a clump of it at the bottom, and the water is mostly clean. Now, the last one we're talking about here is colloids. Now, they're weird. They're sort of like suspensions because it is one substance, one chemical kind of floating around inside a different one. But they can be a mix of any two chemicals in any two phases except for gas with a gas. And additionally, they're also like solutions because they are homogeneously mixed with one chemical dispersed or spread throughout the other chemical equally. The dispersed phase, that's our fancy word here, dispersed, is the chemical you mix in. So whatever you're mixing in is the dispersed phase of this dispersed substance, and the dispersion medium, just the stuff, that is the chemical that's holding the other chemical. Now, colloids are very useful and incredibly varied. There's lots and lots of kinds of colloids, and we use them for tons and tons of things. Now, we have some examples here of colloids, just to show you like how important this particular chemistry process is. So a solid or liquid that you disperse into a gas is an aerosol. That's what we call those. And two examples we see here is Febreze is an aerosol. It's how it makes everything smell better. And incense or other kinds of smoke are aerosols as well. Now here we can see some examples of a gas dispersed in liquid, which is what foams are. So your foam, the sea cream foam at your boba place, that's a colloid. Whipped cream, that's a colloid. Okay. Some more examples here. If you have a liquid within a liquid, milk is a colloid. So is mayonnaise. All right. Now, any substance, this is kind of interesting. Helps us kind of helps kind of see what are colloids and what are not. Any substance with particles of the right size. So if the pieces of that substance are the correct size for this, it will scatter light, which means light will hit it and then bounce off it in random directions, which is how we kind of see light, like in this picture here. Now, it kind of becomes translucent, and so you can see like the sunbeam. They're called God rays sometimes in from old art terms. This happens because those particles are the right size to catch the sunlight and reflect it off a different direction. So you kind of just see light kind of being there. The effect is called the Tyndall effect if you're using the science words. And many, if not most, colloids produce this effect, assuming that the particle is the right size. Now, as these colloids become closer to opaque, so a colloid that is pretty easy to see through, like when we had a couple drops of milk, right, and you can see through kind of easily, the Tyndall effect, scattered that red laser for us. Now, as you get more and more opaque, that effect scatters blue light much more strongly than other colors. So blue gets reflected a lot easier than the other colors for physics reasons to talk about next year. And this is why this glass of flour that's mixed into water looks so blue, even though we all know flour is white with its typical coloration. And that is basically it for our lesson on solutions, suspensions, and colloids. Good luck and talk to you.